Hello, this is Praveen Bodapati. Today I am going to give a presentation on cloud computing with MapReduce and Hadoop. What is cloud computing? Cloud refers to large internet services like Google that run on 10,000s of machines. More exactly, cloud computing refers to services by these companies that let external customers rent computing cycles on their clusters. Amazon EC2 virtual machines at 10 cents per hour billed hourly. Amazon S3 storage at 15 cents per GB per month. Attractive features are scale up to hundreds of nodes, fine-grained billing, pay only for what you use, ease of use, sign up with credit card and get root access. What is MapReduce? Simple data parallel programming model designed for scalability fault tolerance. Pioneered by Google, process 20 petabytes of data per day. Popularized by open-source Hadoop project used at Yahoo, Facebook, Amazon. What is MapReduce used for? At Google, index construction for Google search, article clustering for Google News, statistical machine translation. At Yahoo, we use it for web match, powering Yahoo search, spam detection for Yahoo Mail. At Facebook, data mining, ad optimization, spam detection. What is MapReduce used for? In research, astronomical image analysis, bioinformatics, analyzing Wikipedia conflicts, natural language processing, particle physics, ocean climate simulation. Outline. In this presentation, we go about for MapReduce architecture, examples, applications, getting started with Hadoop, higher level languages over Hadoop, Pig and Hive. MapReduce design goals: scalability to large data volumes, cost efficiency. Here we show the typical Hadoop cluster. We have like 40 nodes per rack and 1000 to 4000 nodes in cluster. 1 Gbps bandwidth with rack, 8 Gbps out of rack. Node specifications with a Yahoo Research are like 8 into 2 times of gigahertz cores and 8 GB RAM. 4 DCRT approximately equal to 4 terabytes. Here we show the figure like how the typical Hadoop cluster look like, and from here onwards the rest is continued by my friend Charan.
Coming to challenges, cheap nodes fail, especially if you have many. Mean time between failures for one node is 3 years, and mean time between failures for 1000 nodes is 1 day. Solution to these challenges: build fault tolerance into system. Commodity network equal to low bandwidth is second challenge. The solution for this one is push computation to the data. Third one is programming distribution systems is hard. Coming to these, the solution is data parallel programming model. Users write map and reduce functions. System distributes work and handles faults. Hadoop components. Distributed file system HDFS. Single namespace for entire cluster. Replicates data 3 times for fault tolerance. MapReduce framework. Executes user job specified as map and reduce job functions. Manages work distribution and fault tolerance. Hadoop distribution file system. Files split into 128 megabyte blocks. Blocks replicated across several data nodes, usually three. Single name node stores metadata, file names, block locations, etc., which are included in that metadata. Optimized for large files and sequential reads. Files are append only. Map reduce execution details. Single master controls job execution on multiple slaves. Mappers preferentially placed on same node or same rack as their input block. Minimizes network usage. Mappers save outputs to local disk before serving them to reducers. Allows recovery if a reducer crashes. Allows having more reducers than nodes. Fault tolerance in MapReduce. If the task crashes, retry on another node. Okay for a map because it has no dependencies. Okay for reduce because map outputs are on disk. If the same task fails repeatedly, fail the job or ignore that input block. If the node crashes, relaunch its current task on other nodes. Rerun any maps that node previously run. Necessary it is because their output files were lost along with the crashed node. If the task is going slowly, launch second copy of the task on another node. This is known as speculative execution. If this is done, take the output of whichever copy finishes first and kill the second one. Surprisingly important in large clusters is stragglers occur frequently due to failing hardware, software bugs, misconfiguration, etc. Single straggler may noticeably slow down a job. Takeaways: by providing a data parallel programming model, MapReduce can control job execution in useful ways. Automatic division of job into tasks, automatic placement of computation near data, automatic load balancing, recovery from failures and stragglers. User focuses on application, not on complexities of distributed computing. And here onwards, my friend Praveen will continue.
Okay. Contributions to Apache Hadoop and its ecosystem. Apache Hadoop is best known for being the open source implementation of Google's MapReduce computing model. Being an open source solution, Hadoop attracted the attention of the both academic and industrial communities. The major reasons for its wide adoption are related to its intrinsic characteristics, namely scalability, fault tolerance, and the ability to perform parallel and distributed computations on low-end computing clusters. Coming to scheduling alongside with storage is one of the most critical aspects of highly concurrent parallel systems and was a topic addressed by a large number of studies we analyzed. Originally, Hadoop comes with three schedulers: FIFO, FAIR, and capacity. The default Hadoop scheduler is FIFO, where the jobs are loaded into queue and scheduled to execute according to their order to queue. The Phase scheduler was originally developed by Facebook and later released to the Hadoop community. It gives a fair share of a cluster capacity to over time, thus its name. Jobs are put into allocated pools which receive a guaranteed minimum number of map-reduced slots. Here we show the hierarchical organization of Apache Hadoop. It contains like map-reduce, data storage and manipulation, ecosystem, miscellaneous. Scheduling data flow and all resource allocation comes under MapReduce, and data storage manipulations comes under like storage replication, cloud storage, cloud computing, indexing, random access, DBMS, and queries. HivePig and HBase comes on ecosystem and the new component also. And energy management, GPGPU, data security, and crypto comes on miscellaneous. Let us see about the data flow. The data processing strategy employed by MapReduce consists of two primitive functions, map and reduce. Behind this simple abstraction, we have to reduce and assign to idle slots of workers according to these two strategies. Thus, there are two types of workers, mappers to map tasks and reducers to reduce tasks in the beginning of the map phase. In the input data is loaded into HDFS. To ensure fault tolerance, the input data are partitioned into equal sized blocks and replicated according to replication factor. Each block will be processed by a mapper, resulting in an intermediate outputs, which are locally sorted, optionally combined from key value pairs sharing the same key, and stored in local lists of the mappers. The reduce phase starts as soon as there are enough map outputs to start a reduced task. Coming to storage and replication, the Hadoop distributed file system is the block storage layer that Hadoop uses to keep its files. HDFS was designed to hold the very large data sets reliably using their data replication. Data nodes are responsible for storing data itself. HDFS works as single writer, multiple reader file system. When a client opens a file, a granted lease for the file and no other client can write the file until the operation is complete. Additionally, after the file is closed, the bytes written cannot be altered or moved except that new data can be added to the file by reopening the file for operand. DBMS indexing queries and random access. Although HDFS shows a good performance on scalability, fault tolerance, high throughput, and flexibility to handle unstructured data, it presents drawbacks in some contexts compared with data DBMS. Energy management. The reduction in cost of hardware enabled corporations to increase the number of data centers and machines. Consequently, energy consumption has become a vital issue regarding costs of data storing and its processing. GPGPU, general purpose computing on graphic processing units. It's a technique to commodity GPUs to perform general purpose computing applications traditionally and based GPUs. The developer job scheduler assigns the map task onto CPU cores and GPU devices in order to minimize the overall map reduced job execution time. Data security and cryptography. In the cloud computing era, data security, privacy, and integrity became important features to be supported by framework and its service providers. In Apache Hadoop, data is stored according to the accounts. The mechanism may not be secure enough when dealing with data spreads across multiple data centers and cloud providers. Some studies addresses these problems, presenting solutions to enhance both Hadoop data security and confidentiality. In open systems, MapReduce faces a data processing service integrity problem since service providers may come from different administrations. From here onwards, my friend Sharon will continue.
Hadoop ecosystem (PIG), which is started at Yahoo Research, runs about 30% of Yahoo's jobs. Features: express a sequence of map-reduces jobs. Data model: nested bags of items. Provides relational SQL operators such as join, group by, etc. Easy to plug in Java functions. Big Bang development environment for an example problem here regards to suppose we have user data in one file and page view data in another. You need to find the top 5 most visited pages by users aged 18 to 25. Here the diagram represents load users, load pages, filter by age, join one name, group one URL, count clicks, order by clicks, and take top 5. Users are loaded into these and filters filter these and pages are loaded and joined, they are grouped, they are summed, they are sorted, and top 5 of them are picked out. Hive developed at Facebook, used for majority of Facebook jobs. Relational database built on Hadoop, maintains a list of table schemas, SQL-like query language, can call Hadoop streaming scripts from HQL, support table partitioning, clustering, complex data types, some optimizations. Sample Hive queries. Find top 5 pages visited by users aged 18 to 25. Select PURL count as clicks from users you join pages. This is which filtered page. This is which the SQL query is. Filtered pages view through Python script. Select a transform puser pdate using mapscript as dt uid cluster by dt from page usp. Coming to the conclusions, MapReduce programming hides the complexity of work distribution and fault tolerance. Principal design philosophies: make it scalable so you can throw hardware at problems. Make it cheap, lowering hardware, programming and admin costs. MapReduce is not suitable for all problems, but when it works, it may save you quite a bit of time. Cloud computing make it straightforward to start using Hadoop or other parallel software at scale. Thank you.